The AI for Good Global Summit, convened by ITU, recognizes the joint responsibility of governments, the private sector, United Nations agencies, academia, and others to ensure AI reaches its full potential while preventing and mitigating harms.
And it's a moment that calls for action. And today I'm calling on each of you to use this summit to help the world to better understand what kinds of regulations, what kinds of guardrails we need to put in place right now. So together, let's make it innovative, let's make it safe, and let's make it responsible for all. Thank you very much.
Welcome to AI for Good, the leading action-oriented, global and inclusive United Nations platform on AI. Organized by ITU, in partnership with 40 UN sister organizations, and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished panelists and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Hello, and welcome to this session. My name is Andrea Manara from the ITU, the International Telecommunication Union. It is an honor for me to introduce the fourth of five final events for the second edition of the ITU GeoAI Challenge. The ITU GeoAI Challenge aims to provide a platform for collaboratively addressing real-world geospatial problems by applying artificial intelligence, machine learning to advance the United Nations Sustainable Development Goals. Participation is open to any individual from any one of the 193 member states of the ITU. ITU provides also a state-of-the-art, free-of-charge compute platform to participants of the challenge who do not have adequate access to compute in their respective institutions. This afternoon session deals with the location mention recognition. We had 138 participants enrolled in this competition and 28 active participants which submit the solution on the Zindi platform. The top three teams were invited for today's session to showcase their solution, and they will be awarded during this session as a recognition for their outstanding performances. The goal of the challenge was to use machine learning for the development of systems for location mention recognition from microblogging posts during emergencies. These automatic systems are anticipated to support the relief activities that are executed by the response authorities during disasters. This challenge is curated by Qatar University, Ahmad bin Khalifa University, Qatar Computing Research Institute, and QN Labs, Inc. Now it is my pleasure to introduce the hosts of this problem statement. Rim Ali Suwalei. If you can switch on the camera.
Hi, Andrea.
Hello, Rim. She's a postdoc researcher at the Hamad bin Khalifa University. Her PhD work focuses on time-critical location mention prediction for social good. And since 2015, she has been very active in information retrieval research with the main focus on social media applications. I want also to introduce Lokendra. Lokendra Chawan is the founder of QN Labs, Inc., which builds AI applications that use the satellite imagery to measure the progress towards achieving the UN SDGs. And prior to founding QN Labs, Inc., Lokendra worked at the Qatar Computing Research Institute, the Qatar National Research Fund, and the Indian Grassroots Business Fund. I will now give the floor to Rim for
Okay.
for her introduction to the competition, and afterwards we will have 10 minutes presentation from each of the competitors. Rim, the floor is yours.
Yeah. You can see my screen?
No, it is still loading. Yeah,
No?
yeah, that's fine.
So thanks, Andrea, for the introduction. I'm Rim Suwaila, postdoctoral researcher in Hamad bin Khalifa University. I'll talk briefly about the challenge, and then we will give the floor to the participants to describe their work, the top actually three teams, and then we will announce the winners. So the organizers, as Andrea mentioned, that myself, Dr. Mohammed Imran from QCRI and Lukandra from Queen's Lab. So before we start talking about the challenge, we need to understand what information or data we have used for the challenge. And for that, the question that I would start with is asking what use do we make of our social media accounts? And as we all know that people usually report whatever is happening around them, and they're mentioning details about the events happening around them, the incidents, and people around them. And this is actually the same what people do during disaster events. So we can, by knowing that, we can use the social media to manage disasters or to support the activities and the operations of the response authorities during disaster events. I'll show you some examples to articulate the need for social media data for the disaster responders. Here are there a few tweets shared during Chennai floods that happened in 2015. As you can see here, people are reporting the incidents happened during the disaster event, and while they're doing so, what they do is mentioning where are the locations of the happening incidents. There are different types of information that we can extract from social media. This includes the flooding bridges or streets, the shelter available for people who have already lost their houses and they don't have a place to stay in. And people also report the closed roads and also request some help from the people around them. They also voluntarily share some help to people in the affected area, as we see here in different tweets on the screen. So by knowing the importance of social media, the task for this year was to provide the participants with a set of tweets, and we asked them to extract the location mentions. But before we go into the details and the task definition, we need to understand what are the types of information that we can extract from social media, and what types of locations that the response authorities care about and need for their work. The first category of locations are the countries, states, cities, which we categorize under the cross-grained locations. Those are very important to draw high-level overview of the ongoing disaster. They are also helpful to assess the impact at the state level or at the country level, depending on the scale of the disaster. This is one example of a map that we can generate using geolocation information. This map was generated by OCHA, in which they show the number of affected people, the number of destroyed and damaged houses in Sudan after the floods happened in 2020. So they show this information and statistics per state in Sudan. The second category of locations are the fine-grained, such as the streets, the buildings, the natural or the human-made points of interest. These are important for the detailed reports. They are also helpful for the relief activities and also for locating and managing the resources. This is another example of a map that was generated using geolocation information by OCHA. They show the location of damaged roads. The landslides happened after the earthquake in Nepal in 2019. So by looking at how the response authorities can use the locations for different for drawing like a high level overview of the disaster, we understand the importance of the geolocation information, and we understand now how we can extract such information from social media. So by knowing the importance of both types of information and like social media source of information and the how we can use the geolocation information, we define our problem as follows. Given a social media post, and here we give example for the post as a Twitter post, which is a tweet. Now Twitter has changed and it's called X platform. So given this post, we need to develop a model that extract all the location mentions inside it that are mentioned within the text. And here in this example, there are two location mentions that are Baravor and the other district. This is another example for another tweet with different types of locations. Here we can see the fine-grained locations such as the Greek and the road and avenue that appear within a tweet was shared during floods. So once we have developed these systems, we need to evaluate them. And to do so, we have used a data set for this competition, which we call ADRIS-CR. We use the English version of it. ADRIS-C contains more than 20K English tweets. Those tweets were collected from disaster that happened between 2016 and 2019 in English-speaking countries. The types of disasters involve hurricanes, earthquakes, floods, and wildfires, plus one cyclone. And those tweets were already labeled for information types that are of interest to the response authorities, such as caution and advice, displacement, missing people, requests, among different types of information. As I mentioned, the disaster events happened in more than 14 English-speaking countries, and the dataset contains around 22 location mentions of different types, and we have labeled it using in-house annotators, and we showed in certain publications the quality of this dataset and the generalizability of models trained on this dataset. Now, once we're done with once we're done with training LMR models, then the next is to evaluate them using different evaluation measures. And here we're using the standard precision and recall in the second round of evaluation. And the final score that we use is F1 score. These different details about how we run our evaluation. We have also provided for participants two types of baselines. The first one is BERT-based by a baseline, which is sequence-to-sequence model. And the second one is conditional random field, which is one of the traditional but competitive models. So now I'll let the floor for the participants to discuss their participation, how they modeled their solution, and what they did for their models and submissions.
So, thank you very much for this nice introduction, Reem. So let's go with the participants now. So maybe Mohammed, you want to start?
Okay. Give me a second. Okay. Um, mm, it's- my screen's. You see
Yes,
my screen?
yes, we see the screen. Now if
Okay.
you start presentation, we see it. Excellent.
Okay. Okay. Hello. I'm Mohammed Adel, computer science student at Nile University in Egypt. And here we talk about my solution to the problem, location mention recognition. And here is overview about the problem. Um, as Dr. Reem said, in disasters, a lot of people like tweeting about, for example, in disaster like earthquakes, a lot of people tweeting about locations, something like infrastructure damage in street X, district Y. So we need an automated process to recognition of these locations. And this is the goal of this challenge to encourage development of the systems for location mention recognition. And why we need AI for such a problem. Here is an example. If our problem were only to detect countries or cities, we can use all the gazeters that contain, for example, all the world countries and cities names, and that's it. But our problem is not that simple. We have to define fine-grained locations. Like in this tweet, dear friends, there's two roads, a street, district. So here we use AI to solve such a problem. I'll talk about some of my methodology. Datasets I used, pre-processing, model, and training. Um, the dataset I used is IDRISI dataset um, which is the largest public available location mention prediction dataset from Twitter data, namely X now. And the second dataset I used is not 16, which is used in named entity recognition and Twitter data. Why I used this dataset? Because its distribution almost similar to Idrisi, so close. Like it's a Twitter data, same style of text, informal English, like a lot of mentions, hashtags, etc. So it helped to improve the performance. The Idrisi dataset used a PyLo tagging scheme, which is began inside last unit outside. Here is an example. If we have a country like South of Africa, the begin of the location south of is inside location, Africa the last word, or unit like a word like Egypt, it's a single unit location, or a man outside the location. But Node 16 use the bio tagging. It consider of an Africa the same. It's inside allocation. South is the beginning. Egypt is considered as the beginning and man outside. So that's lead to the first pre-processing the step I did is to unify the tagging scheme for both datasets. I use BioS tagging, which is similar to BILO tagging, and unified all locations types to location. Like for example, here at RISI dataset, the United States beginning of country and inside country, last country. So it became uh, beginning location, inside location, end location, and the same for Linode 16. I made it by stacking also, and I did not use any gazeters as it didn't help the performance. It only contains like world countries and famous cities, so for me it doesn't help the performance. For a model, I used Flare, which is a state-of-art NLP framework. used in many tasks like named entity recognition, which is our task. And it's also it allows us to import or use embeddings from Hugging Face. I use the Berta V3 Large from Microsoft, was trained on a big corpus onto Notes 5 for training, and uh, it also helped to blow up the performance. For hyperparameters, I train three epochs, learning rate 5, 10 power 6, no, negative 6, mini batch size was 8, optimizer was AMW. And for the scheduler, I used one cycle learning rate. I deactivated the RNN and CRF and added activated a reprojection embedding layer. That was mainly the approach. The main thing which helped the performance was pre-processing step and using Flare with large embedding from Hugging Face like Tiberta. And the evaluation metric used in leaderboard was RMC, root mean squared error, between the obtained indexes and true indexes. For example, here is example output, Jammu and Kashmir. Jammu start at index 0 and end at index 5. So the um, the evaluation metric was here follows this example. The RMC is 0 as it actually gave us the true indexes. So the paired baseline was 1399.99 RMC, and our model was 12.7 and leaderboard. Um, that's it for the solution. And lastly, what's next? There is two things in my mind. First thing is to improve the pre-processing and post-processing steps, like using removing hashtags, mentions, and this will require also a post-processing steps to detect the indexes right. And second thing to solve this challenge, but this time in Arabic, my language, which is available dataset, surprisingly good in Arabic, Idrisi dataset. Um, and that's it, a summary of my solution. And thank you. شكرا.
I thank you very much for this nice presentation of your solution, Mohammed. Now I would like to give the floor to Nabarut. You can please.
Yeah, thank you. Hi, I'm just sharing the screen.
Yes.
Okay, first, thank you for giving me the opportunity to be a panelist here. Okay, let me just first. Okay, I'm Nabarup. I'm a professional data scientist, and okay, the challenge is pretty interesting and it's practical though. Okay, as Reem has shared earlier. So these are the agendas in my discussion today. First motivation, then what are the main components of the solution, then what are the feature engineering I have done, then model architecture, then evaluations, and what are the limitations and how what could the future work. Okay, let's start about the motivations part. So the problem statement, the what and why part, I think this has been already discussed by Reem. Okay, so what we are doing, so our problem statement was so that micro blogs posts are important to find the geotag locations. Okay, and there is a high volume of blogging posts, so manual extraction is not possible. Okay, so our aim is to identify the location mentions in those Twitter texts. Now, what we are doing, so how we are mitigating it, we have done a lot of data explorations, then feature engineering. We are using state-of-the-art ML algorithms. Okay, so here I have presented a possible solution using BioLSTM plus CRA. Okay, so the fitted model, it is performing fairly well, and it's predict on unseen data with relatively higher accuracy. Okay, I'm simply going to the next slide. So these are the main components of my system. So I I have not used any gazetted, first of all. Okay, I have used the challenge data that is like mentioned in um, Idrisi data format, JSON format. I have used trained for training and validation data for validations. Then I have done some data explorations, some statistics about the data, how the pattern looks like. Then for data preparations, I have used PACY. So that is also a NLP based tool. So for tokenize the input text. Then I have done a lot of feature engineering that we'll discuss later. I have not mentioned it here. We have a separate section for this. For external data, I have used Glove for embedding of our input text. Then our model, when the model is ready, we have tuned the model based on some parameter. Then once the model is ready, we just simply pass it to the text data. So same text data, we have taken it from that Idrisi, and we are not exploring that. We simply prepare that whatever we have done based on train and validation set. Then feature transformation we have done, and using the trained model, we are able to find what are the location tags. Now, when I found what are the location tags, then there is a code for identify the location indices as well. Okay, so this is the overall process. Then feature engineering. So at a first step, what we have done, so we first build a dictionary for all of the words we have available. So for unknown words, we put 0, and for padding, we pushed 1. And so the sample is look like this. The sample is look like this. Now at the second step, so as you see in this picture, we extract the features X and Y. So for you can say these are the words after tokenizations for a single sentence, and these are their labels for this word. This is the tag. Okay, so if the tag is related to the locations, I put LOC, and for others, I put O. Then at the next step, I encoded them, whatever we build that dictionary from that dictionary. Okay, and from class level we have used, for others we have used 1, and for locations we have used 2. Then at step 4, what we are doing, we are using padding because it's needed for the model. So after padding, the same data will look like this. Okay, and in this case, as we have padding, so class level will become for others it's 1, for location it's 2, and for padding it's 0. Now I'll simply jump to the model architecture and hyperparameters. So this is the base architecture I have used. So if you can see, this is the one LSTM and forward, and one LSTM is backward, and on top of that there is a CRF layer. Okay, so this is the CRF layer, this is the backward, and this is the forward, and these are the inputs for a BioLSTM architectures. And yeah, for CRF, so in TensorFlow only it's available. CRF model wrapper, I have used that. So these are the hyperparameters I have used. So as of now, these are the optimal. Okay, they can be tuned. It's a future task to tune it more. Okay, but as of now, these are the hyperparameter I have used. For optimizer, I have used Adam with 0.02 learning rate. Batch side, I have considered 128, and 3 epochs I have run. I'll come to model evaluation now. So I have mentioned for different tags. I've mentioned this is actually the offline. This is actually the offline evaluation, not the online based on the leaderboard. Okay, so as an offline evaluation, I have, so these are the confusion metrics you can check, and what are the accuracy from here, that also you can check it here. For locations around 99%, for others also 99%, and for tagging it's 92%. Now we'll come to the model dependencies part. So it's I have built the entire thing in Python. So so it will be required to the Python based packages. It's needed there. Then I have, for tokenization, I have used Spacey, that small model I have used. Then to take the JSONs into to convert the JSONs into text, I have used JSON lines library. And to plot the errors, I have used that plot errors history, this library. And for TensorFlow add-ons, because CRF is not there in normal TensorFlow, you need to install TensorFlow add-ons there. And as an external data, I have used Glove embedding. So that is developed by the Stanford developers. And I have used the small one with the size of each word size of 100 vector that I have used. Now let's come to the limitation. So what I have seen, even you can also check, the model is sensible to the sentence length. Okay, you can't make it too high because it's actually the limitations of the LSTM architecture. Okay, and what I have seen, the model struggles to identify the locations if they are co-occurred with other characters. Means you don't know where to split. So if we simply split them, then only it become locations. And in those perspectives, it has some limitations. And yeah, of course, it's has some overfitting based on the training data. So you can't simply put any kind of test data here. Okay, so similar to training data, if you put the test data, it will work well. Okay. Now, so for future work, what I want to do, so if you check the limitations for that, if the locations are co-occurred with other words, so in that perspective, what is of is using a character level encoding. So only using a character level encoding, you can fix that. But and I have seen in some cases the spellings are also wrong because there are so unnecessary characters there because it's a Twitter data. Okay, some emojis or other kind of things. So we need a smart spell checker for that. And yeah, to some extent, we need to improve the Spacey tokenizer as well. And apart from that, I want to use the BERT embedding as well. Actually, I have applied the BERT embedding instead of Globe, but what I want is BERT embedding. Just simply tune the BERT embedding. Okay, that I want to use, and I wanted to use some other models based on transformers. Yeah, that's it. Thank you. If you have any questions, you can ask.
Thank you very much, Navarro, for this very interesting and clear presentation. I'd like now to call the last speaker, and then we can have a discussion at the end. If Victor, you can return your camera and share your screen, please.
Okay, thank you so much. I'll just share my screen in 1 minute. Right, just let me know if you can see my screen.
Yeah, we can see it. If you can start your slideshow. Excellent.
So, okay. Hi everyone. My name is Olufemi Victor. And on Zindi, my username is Professor, even though I just got my bachelor's degree from the Obafemi Awolowo University. Also, currently doing the presentation on GeoAI Challenge Location Mention Recognition on social media, which was organized by ITU. Okay, so the problem statement has already been well passed across already in the earlier presentation, but essentially what it entails is to be able to pick microblogs or posts from any microblog, Twitter being an example, and find or locate location mentions within the structure of the text. Okay, and on doing my research for this challenge, I've already provided were some baseline models which I was able to leverage. And for the English Idrisi data set, about 4 models were already provided as baseline models. But you see that they already achieve a very high precision, recall, and F1 score, as reported via the paper. And also, the 2 models that are here are actually the best and the worst. That's the best case scenario for the English Idrisi data sets. Already achieves a score of about 97% precision and an F1 score of 97 as well. And the worst case scenario already does pretty well as well, achieving a score of about 90.4%, and both in precision and recall. And so what I did instead was to focus on the other sides, which is the data, focusing more on the outputs and the inputs of the data instead of focusing on the model. And on doing this, I came up with some methodologies. I also used the Python framework to achieve all this. And my methodology simply involved creating a bunch of pre-processing and post-processing techniques, and leveraging the already available baseline models to achieve my score. And the baseline model, although has an RMSE, which was the metric that was used on Zindi, gave us about 13.9 plus percent, 13.9 plus for the RMSE score. And I used a bunch of pre-processing and post-processing techniques, which I'll come to shortly. And I also did an ensemble. So I used for this hackathon, I used both the best as shown here, that's the best model, and the worst model as reported in the Idrisi paper baseline, right? And I combined 50% of the time-based typeless, which is the best, and also 50% from the random type-based, which is the worst performing model. And the best performing model already also still, achieves the top performance, which is 11.92. And on assembling, also, I was able to achieve even further, greater performance, giving me 11.19 for the RMSE. Okay, so let me just quickly dive into some of the techniques that I used. So the first one is a function I created called the mentions destroyer. And essentially what it does is just to remove the mentions. And this is essentially because sometimes mentions in the text confuses the model, especially because, they are names of, of the post and not necessarily the location that is being mentioned. So that's essentially what the first function does. It helps, to avoid model confusion, as well as preserve text length. That's why, just converted them to question marks. And the second function as well, which stood out among several others, is the post-process prediction function. And this is a post-processing technique. And what I did here essentially was quite simple. So on from the output of the model, we discover sometimes that the model brings out, of course, the model is a token classification model, which is based on the BERT model and fine-tuned already on Idrisi datasets. But the model brings out, of course, classifying tokens brings out sometimes the words in are being splitted. So you have a very high score, but of course you have the location being splitted. But it was quite easy to detect because the words were always very close to each other. So where you have a start position being 60 and ending in 64, you'd see the next location starting at 65. So a simple technique was just to, destroy some of those, very close gaps and instead combine the words together. So on doing this, instead of having Cape, Fair, and River as separate locations, you have one single location, which, clearly represents the ideal location. And lastly, I also created a function. This is one of the functions that also stood out as well, and it's called the entity fixer. And essentially what it does is very simple. It simply takes the predictions, and of course, as I said earlier, the predictions from the BERT model are tokens, right, instead of words, which are similar to words, but are not complete words. So it breaks, some of the locations are broken down into tokens. And that's why you see sometimes the word is incomplete. Like for this sample tweet, you should have Leyland, but of course you're having just a token, LE or Lee. So a simple way to track this kind of challenges was to simply check if the word was complete or incomplete, because you see a very high confidence score here of 91.6%, but of course a wrong output from the model. So a simple way to actually help the model get better predictions was to simply complete the word. So to check if the word is complete and essentially complete it and correct the start and end positions since I already have the correct word. So just to quickly wrap up, why does this solution stand out? Pretty much because it just leverages the baseline model, and of course it's entirely in its nature very simple. There was no fine-tuning, no gazetteer, no extra data or external database that was used, which shows that there's much more room for improvement, even though it achieves a remarkable score on the leaderboard. And for a limitation, I would say, depending on the use case of the model, if it's going to be deployed on a mobile and depending on the compute required, the only challenge was that the baseline model was quite large. So what next, right? The Docker image has already been released. And there are also several other ideas to try, better baseline models, because currently the solution uses the best and the worst baseline. And there are several ideas to also try the best two or the best three instead of using the best and the worst. And also we could further use, gazetteers to refine the predictions, and also try to leverage more pre-processing and post-processing strategies to ensure you squeeze out optimal performance from the model. And also, if there's more data, there's definitely more room to fine-tune the model and make it better. So that will be all from me. Thank you so much for listening once again.
Thank you very much, Victor, also for this very nice and clear presentation. Now is the time to give back the floor to our hosts, so Rim and Lokendra, and then they will make an analysis of your submissions, and then they will announce the winners.
Yes,
Rim,
thank you, Andrea.
the floor is yours.
Yeah, thanks for all participants for the informative presentations, and thanks also for the participation this year. We hope to see you in the upcoming versions of this challenge. Next, if Lakendra doesn't have anything to say, I'll go immediately to the results.
Yeah, I don't have anything to say. Because
Yeah.
you already covered everything.
Nice to see you here.
Thank you.
Lakendra.
Thank you so much.
Thank you. So let me share my slides again. And before we talk about the winners, we need to highlight that we've got this year a very good number of teams who enrolled, which is 138. 28 of them were active, and they made several submissions for the on the leaderboard. And then we shorted list all the submissions and got the top 10 and invited them for a second round of evaluation that I'll discuss shortly. Then the top 3 were invited. Those are Mohammed Adil, Victor, and Narab. Narab. I hope I'm pronouncing your name correctly.
Yes, it's
So yes, this is the leaderboard, which is the online evaluation that we kept online, and here you can see the ranked teams, in which we're only showing 8, but those are like the top ones based on mean squared error evaluation measure that used by Zindi platform. Now, the second round was based on 3 criteria. The evaluation was based on 3 criteria. The first one is the system performance using the F1 standard measure, which is used in literature for this type of competition, or for this task of sequence labeling, which is LMR. We also used the reports submitted by participants, and we evaluated them. And also the third criteria was the novelty, and the technical work was done by the participants. And by that, we have identified 3 top teams, and those already give like informative presentations about what they have done. And next is the announcement of the results. And before that, I would kindly ask everyone to switch on their cameras. Yeah, Mohammed, still there? So is Mohammed here, or he left?
I share.
Here, but I don't see the
He's
camera. Okay, it is. Now I see the camera is so nice. I can make a nice
picture.
Sure.
Yeah. Thank you.
All of us. And we will also announce the winners.
Yeah. Now, starting with the 3rd place, Victor has won it. And here we're showing the certificate that we will share with the participants, plus the prize. So congratulations to Victor, and I hope we can hear a word or a statement from Victor.
Yeah, definitely. Yes. A big appreciation to, the whole team, and for organizing such a wonderful challenge, and especially to ITU and everyone at Zindi as well. Yeah, thank you so much for the award and the prize.
Thank you, Victor, and congrats again. So we go next to the 2nd place, and that goes to Nabara. Congratulations, and yes.
Thank
the floor
you,
is yours if you want to say anything.
Yeah, thank you, Vivian. So this is my first appreciation from Jindy. I'm glad. Okay, and yeah, thank you, ITU, and thank you for for this.
Thank you so much. And the 1st place goes to Mohammed Adil. Congratulations, Mohammed. Hope you want to say
Thank
anything.
you.
Yeah.
And thank you for organizing this challenge, interesting challenge. This was my first time in Zindi. So thank you, and thank you for the work you have done, especially for me in Arabic. So
Great.
thank you, and
Great to see someone who's working on Arabic on this challenge, because it's low resource language, although the competition was only for English. So it's very nice to hear that from you.
Yeah, I plan to solve it in Arabic too. So
perfect. Then let's talk
inshallah.
about it, like the collaboration that we can make. Yeah. Thank you so much, and thanks a lot to Lokandra and Dr. Mohammed Imran, who did not manage to make it today. Thanks a lot to ITU to Andrea and Thomas for their continuous support and help. They did like a very great effort for this challenge. And now I'll leave the floor for Andrea if you want to say anything.
Thank you very much, Rim and Lokendra, and thank you very much all the participants. It was a very, very interesting event with very interesting solutions that were presented. Yeah, what I would like to ask all of you is that if which is your feedback out of this competition? If is there anything that you think that we should improve? And then I would like also to ask Rim and Lokendra if you have any plan for next year. Who want to?
Yeah, for next year we're planning to study the visibility of running it for multiple languages, not only English. So we're still like studying that. This is the first thing. We're also planning to maybe do both, because this year we were only working on typeless LMR. Now we want to include multiple setups to evaluate systems. So this is what's in my mind currently. Not sure if Lakendra has other plans.
So I think I can add one small point there, which is
Yeah.
so considering the rise of LLMs, and I've gone through some papers where like we can see that LLMs have done pretty well at location mention recognition or token name recognition, etc. So so rather than, let's say, but then they've not done well on what you can call as geographic question and answering. So maybe the challenge could be more about that, okay, you can use probably the ChatGPT or some of the LLM, but it's not that you are just trying to ask, okay, which location or place it is, but you are asking a specific question about, okay, it's a disaster situation, where do people need most help for like medical related help, or where do people need food? So now this is a question which they have to not just infer the location, but also what is the need, or what could be more urgent. And also it's a more complex question, and I think how to fine tune those models to improve upon those could be a good idea to explore. Because making these specific models could be, I'm like, it's just like, I've gone through some papers and I realized that, okay, the ChatGPT is already outperforming the specific models, partly because they have been trained on such huge data sets. So I think we could just focus on a different question where ChatGPT is not able to give good answers, which is when you include location and you want more like world. Basically, it has to be able to make sense of the situation itself, which is what the purpose is finally.
Yeah. For that, we will need to study the computational resources that we can support the participants with.
Yes, obviously.
Yeah.
But it's just an idea. I'm sure like we'll have to discuss and decide on what.
Definitely. Yeah.
Thanks. Cool. I guess participants, if they want to say something.
Yeah. Any feedback? If no feedback, I would like to make an announcement. You might also be interested in these activities. We would like to announce the launch for a call of paper for a special issue. Let me share my screen on a special issue on geospatial AI. Rim, if you can stop sharing. Okay, thank you very much. Share my screen. Yes, we have launched a call for paper for a special issue on geospatial AI to advance the United Nations SDGs in the ITU Journal of Future and Evolving Technology. And the leading guest editor is Maria Brobelli. She's leading many of the GeoAI activities in the ITU. So we are looking for submissions. The submission for the papers is the 1st of March. And what to say, for all of the competitions, we encourage submissions from the winners. So you all three competitor which achieved remarkable results. If you are interested in working as a team and come up with the submissions, and maybe Rim and Lokendra would also want to be included in the effort. So it's actually a suggestion for continuing this discussion, also with documenting what you did in this competition. So after this, I think that we are getting at the end of the event. Is there anything new that Rim and Lokendra would say, or?
Thank you, Andrea. Thank you, Andrea. And thanks for also Thomas, who's behind the scenes.
Sure. Thank you very much, all. Then, thank you all the participants.
Thank you, Thomas and Andrea. Yes.
Thank you very much.
And thank you so much, Reem.
And I thank again Mohammed, Nabarut, and Victor, which have presented, and they did an excellent job, and also to all the other competitors who have actively engaged in the competition. I thank again Lokendra and Rim and everybody else in the host organization. I wish also to remind you that this session has been recorded and is available in YouTube and on the neural network. I think that we are beginning to have a very impressive GeoAI educational material, AI for good. And with this, I think that we can close the session. I thank you very much all again.
Thank you for participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. We invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the eShop, and build your personalized AI for Good program. Let's shape the future of AI for Good.
The AI for Good Global Summit, convened by ITU, recognizes the joint responsibility of governments, the private sector, United Nations agencies, academia, and others to ensure AI reaches its full potential while preventing and mitigating harms.
And it's a moment that calls for action. And today I'm calling on each of you to use this summit to help the world to better understand what kinds of regulations, what kinds of guardrails we need to put in place right now. So together, let's make it innovative, let's make it safe, and let's make it responsible for all. Thank you very much.
Mm-hmm.